One more example on solving quadratic equations. So this example right here, it may not look like a quadratic function right away when we look at it, but if we transform it a little bit, then this will transform into a quadratic equation. So sometimes we may, the equation that we see may not look like a quadratic equation to us or a quadratic function to us directly, but we can transform, we can do some simplification, and then we may be able to, then we will be able to see that it actually is a quadratic equation. Okay, guys, there's again a big section in this quadratic functions unit where like the equations may not look like quadratic equations, but they can be transformed into quadratic functions, quadratic equations, and then we can use the factoring method or the quadratic formula to solve for x. So to solve an equation like this, the first thing we want to do is we want to classify this into a certain type of a function. So it is obviously not a linear function. So how are we going to see that it's a quadratic function? We can easily do that by distributing this 2x with the parentheses. Okay, so you got to multiply or distribute this 2x. Or when we do it, what do I get as my first term? I get 2x squared, and then 2x times -1 is -2x, and equals to +3. Well, I have an x squared term, and the coefficient in front of x squared is +2, so x squared term is going to stay. That means it's a quadratic form, and it looks almost like a standard form. There's only one thing we have to do to get it exactly in the standard form, which you already know by now, is that we have to subtract 3 from both sides, and we want to get a 0 on the right hand side. So let's go ahead and subtract 3 from both sides. And this looks like 2x squared minus 2x minus 3, and the right hand side we have a 0. So this is in the standard form, right? Guys, once this is in the standard form, again, the first thing we should try to do is use the factoring method. If it works, then we got to use that one to find the x. If it does not work, then we'll go to a quadratic formula. Okay, so first let us try the factoring method. So for factoring method, I take this 2 and multiply with -3. What do I get? I get a -6. Then I try to come up with two factors for -6 so that they add up to -2. So let us try to write the factors. I have 1 and -6. I can have -1 and 6, but no, if we add them, we're not going to get -2, so it does not work. Then the next one is 2 times 3. Well, let's put a negative in front of here, 2. So -2 plus 3 is not going to give me -2. Even if I switch the negative to 3, it's still not going to, when I add them, it's still not going to give me -2. So I think that's all. I mean, I don't have any other options for as far as the product for two factors for -6. So the first one does not work, the second one does not work. So it seems like we cannot factor this quadratic polynomial. Okay, so that means the factoring method does not work here. If factoring method does not work, obviously then we have to use the quadratic formula. And for quadratic formula, we have to identify a, b, and c. A is 2, b is -2, and c is -3. Guys, you have already seen how to use a quadratic formula to solve a quadratic equation, so you may be able to do it on your own, but here I'm going to still solve it for you. And then if you try to do it on your own, you can always like check the work. Okay, so let us use the quadratic formula again. First is just writing out the whole quadratic formula. So x is -b plus and minus square root of the discriminant b squared minus 4ac divided by 2 times a. And now let us substitute the values and let's see what we get. So when we substitute the values, let's see what we have. I have x equals to negative times -2, okay? Because b is -2 and there's already a negative from the formula, so I have to put that in parentheses, then plus and minus square root of b squared minus 4ac. So b squared -2 in the parentheses, square that, minus 4 times a, which is +2, and then times, I still have what? I have c, which is -3. So I like to put the negatives in parentheses. I even like to put sometimes the positives in parentheses, but here I'm not going to put it. It does not really matter. Now I have divided by 2 times a. So 2 times a is 2 times 2. 2 times 2, okay? Guys, I like to write out the steps mostly all the time, but if you're like very confident with your work, I mean, you may skip some steps once in a while. So negative times negative is positive, so it's positive 2 plus and minus. I'm going to try to simplify this without using a calculator. So negative 2 squared is 4, right? And then this is negative and negative becomes positive, and 4 times 2 is 8, 8 times 3 is 24. Got to divide the whole thing by 2 times 2 is 4, right? Now simplifying further, this is 2 plus minus square root of 4 plus 24 is 28 divided by 4. We're almost done, except for we have to try and see if we can simplify radical of 28. Guys, keep in mind, most of the times we want to keep it the whole final answer in terms of radicals. And if you are looking at a multiple choice thing and you have decimals as the answers, then one wants to convert that radical into a decimal. Otherwise, we want to keep everything in radicals. Radical 28 obviously is not a perfect square, so what we have to do is we have to try to come up with 2 factors of 28. At least one of them should be a perfect square. So luckily for us, we can find that 4 times 7, right? 4 times 7 is 28 and 4 is a perfect square. So we can bring it back here. It looks like 2 plus minus square root of 4 times 7. I just broke 28 as 4 times 7. Why 4 times 7? Because we want one of the numbers to be a perfect square and 4 is a perfect square. The other one, 7, is not a perfect square, so we cannot do much with that. Divided by 4. Guys, please look at the next few steps carefully. So from here, we got this. And from here, I'm going to take it up right here. So we got 2 plus and minus. And when we simplify this, it is radical 4 times radical 7. But what is radical 4? Radical 4 is simply 2. And what do we do with the radical 7? We don't do anything with the radical 7 because it cannot be simplified any further. So we just keep it as radical 7. So it is 2 times radical 7. And this whole thing has to be still divided by 4. Guys, we're almost done. Now this 2 and this 2 in both the terms is a common factor. You can take it out. You're left with 1 plus minus radical 7 divided by 4. Guys, I see a 2 here, I see a 2 here. That's why I was able to take it out as a greatest common factor. Once this is done, 2 and 4, it's 2 times 1, 2 times 2 is 4. So the final answer is 1 plus minus radical 7 over 2. That you can leave the final answer like that, or if you want to write it out as two solutions, then we can write this like x equals to 1 plus radical 7 over 2, and then the other solution is x equals to 1 minus radical 7 over 2. This is the final solution. Okay. So nothing really special about it, except for the fact that we had to first distribute this 2x so that it looks like a standard form, and then once we see that it looks like it's in the standard form, then we just simply identify A, B, C, use the quadratic formula. When you have a radical, you got to simplify that carefully, then bring things together. Where there's a greatest common factor, you got to take it out, simplify, and then if you want to write it as 2 separate answers, that's how you are going to write it. Okay, guys, that ends for me right now solving quadratic equations. We did factoring method, the quadratic formula, and we looked at more than few different types. Okay, so in the next video I'm going to talk about the vertex form. Remember, there's 3 forms: the factored form, standard form, and the vertex form. We looked at the standard form. We also looked at some of the factored forms because these factored forms show up, and then now we have to look at the vertex form. Okay, till then, guys, keep practicing these problems and let me know if I can help you in any way.